Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will continue the lessons on M1. We have reached to lesson 6, which is on equilibrium and acceleration under concurrent forces. And you know it is A-level mathematics. In the last lesson, which was lesson number 5, we covered resultant and component of forces. You can find the link in the description below for all the lessons on M1 we have made so far. So in this topic, which is on equilibrium and acceleration under concurrent forces, I have made 4 videos. You can see here how I'm dividing it into. So the first video 6.1, which is the current one, will cover triangle of forces, Lami's theorem, polygon of forces, particle in equilibrium under more than 3 forces, and solution by calculation. So let's start. First of all, a very important concept, triangle of forces. If there are two forces which are represented in the diagram by the line segment AB and AD and named as P and Q, the resultant of these forces will be AC if you complete the parallelogram. And how will you write it? If you see here, AB plus BC is equals to AC because the force AD is equivalent to BC. And from here, what do you get? You get, if you add minus R, because R is the resultant and minus R is the opposite direction. If you add minus R in two forces P and Q, the answer will be equals to 0. And that shows that it is in the equilibrium. It will be in the equilibrium then, right? Now, so let's see forces in equilibrium. So we have seen when the net force acting on an object is 0. So overall the net force is 0. Then it will be equilibrium. This means all the forces acting on the object perfectly balance out. Now we will see here that forces are acting in different angles. So what we will do, we will divide the forces into components, and all the component along the x-axis should be equals to 0, and all the component of forces along y-axis should be equals to 0 if we are talking about x and y-axis. If we are talking about ramp, then all the forces perpendicular to the plane and parallel to the plane. If they are 0, parallel ones are 0 and perpendicular ones are 0, then the object is in equilibrium. So we will have a better understanding with the help of the examples. So here you see we are talking about Lami's theorem now, which is used only when there are 3 forces acting on the object. And Lami's theorem says that the ratio of the magnitude of force with the sign of the angle between the other 2 forces is the same. So if you look at this diagram, let me take a force A first. So the angle opposite to it between the 2 other forces is alpha. So ratio will become A over sine alpha. Similarly, force B, the angle opposite to it between the other 2 forces is beta. So it will be B over sine beta. And similarly, C over sine gamma. So all these ratios will be equal. So let's see one example here. And at times you have to sketch first to understand it. So you should be ready for that also. And most of the time, the sketch is given to you. A ship is held in equilibrium by ropes on a bearing of 120 degree and 220 degree. And wind is blowing north, exerting a force of 90 Newton on the ship. So first of all, you have to sketch it, and then we will find out the tension in the 2 ropes. So these are the ropes. This is ship. These are the ropes, and this is the wind blowing in the north. So you have mentioned all this. And this is easy to write here. Why? Because 360 minus the sum of these 2 angles. Now if you have to find the tension in the ropes, so how can you write? 90 divided by sine 100, T2 divided by 120, and similarly T1 divided by this angle. So it will help you to form the equations, and you can find the value of T1 and T2. Now it is the time for you to test your understanding. So you can put the video on pause because I will show you the solution here, and then you will do it. You will check it. Now something before I show you, very important, like this is unknown and this is unknown. Common misunderstanding is students immediately take it as 45. You cannot assume that. You have to see either it is 45 or not, because there is no information given here in the question. So how will you figure that out? This is a straight line. A straight line is 180 degree, right? So if you do 180 minus 45, what will you get? 135. Absolutely right. So this is your 135. Then what is this angle left? 360 minus all these angles will give you 30 degree. I'm using calculator, so you can also use it. So once this diagram is complete, then you can easily apply the Lamy's theorem, right? So exactly I have written the same thing. 8 Newton is opposite to 150. P Newton is opposite to sum of these two because this whole angle. And similarly for Q, it is 135. So now you can pick up, for example, first these two to find the angle of force of P, and then this with this. I'm sure you would have done the same thing. I just explain here once again so that you can check your answers. Okay, so in the last you must answer separately, which is asked in the question. Now, particles in equilibrium under more than 3 forces, solution by calculation. So I have taken here this solved example first, and I will show you how to resolve it so that we have a recap also. So we will solve it along x-axis and along y-axis. Sometimes name is used along OX and along OY. Okay. So first of all, parallel to x-axis, how many forces are here? If you see it is 10 Newton in this direction, this 7 Newton you will resolve into x-axis and y-axis. This will become your 7 cos 60, and this along y-axis will become 7 sin 60. Similarly, this S Newton, it will have direction here and down. So this will be S cos 30 and this will be S sin 30. Right? So now along x-axis if we see 10 is equals to, because there are two forces, sorry, this one 10 and this one also I have written here 7 cos 60. So they both are acting in this direction. So that's why they are added. And on the left hand side only one force is acting, which is S cos 30. So this is how you will simplify left hand side and you will get the answer of S. Now along y-axis if you see here, it is this force which is acting upward. Sorry, this one 7 sin 60 is acting upward, and this force is acting downward, which is S sin 30. Right? So I will write an equation here, and this P is also here, which is vertically up. So this and this force will be added up, and this force is downward, opposite direction. So we are putting it equal to, because the object is in equilibrium. So all the forces upward are equals to all the forces downward. All the forces acting on right equals to all the forces acting on left. And then you are simply solving them simultaneously to get the answer. So let's solve this question step by step so that there is no confusion. Okay. So let's start. I'm explaining here. After that there are two more questions which I have solved, and that will be test of your understanding and your assessment also. So let's see along x-axis first of all. Okay. Along OX according to the question part A. So I can see it is 5. This one you can see here, and force P I will resolve into two parts, along X and along Y. So this will be P cos theta and this will be P sin theta. So it will be P cos theta. Okay. Then on the left hand side, if I see here, let me change the color. So if I see here, it is this one, right? So this is 10 sine 20 and this is 10 cos 20. Now it is acting on the left hand side. So I will put it 10 cos 20. Now 10 Newton, which is acting downward, is also, if you resolve, will act left and down. So the one which is on left is called 10. Acha, by the way, if you are resolving it from here, then you need to have this angle. But if you want to use 20, let me use 20 here so that you can also understand, because you just have to resolve it parallel and perpendicular to OX and OY. So suppose I'm resolving using 20 degree. So I will write it here. This will be my along OY. This will be along OX. So along OX is this. It is 10 sine 20. Right? And this one will be 10 cos 20. If you have used this side along the x-axis, then you need to find this angle, which will be 70. So then you have to write with respect to 70. So in both ways it is fine. So I am using right now what is given in 20. So it is plus 10 sine 20, right? Because this force is acting in the left hand side direction. So this will be my equation 1, because question is obtain an equation. After that we can simplify it also. Let's simplify here, then we will obtain OY. So P, just a minute. So it is P cos theta. I'm taking 5 to the other side and I'm putting all the values in the calculator. Give me 1 second. So I'm first of all putting the right hand side in the calculator. So it is coming 12.817127. Why I'm writing into so many decimal places? Because I have to use this answer later. So I don't want to get the final answer wrong. Okay. So I don't need to round it off here. Just a minute. So this is my value of P cos theta. I will keep it here. Now let's resolve it along OY. Okay. So I'm calling it equation 3. Why 3? Why not 2? Because the one I will get along OY, I will call it 2. Okay. Anyway, that is not an issue. You can give any name to anything. Now along OY, if I see which forces are acting upward, it is this one, right? So I can say P sine theta plus 10 sine 20. So P sine theta plus 10 sine 20. These two forces are acting upward. This is the resolving force of the force P and 10 along OY. Now which one is acting downward? It is this one, 10 cos 20. So I will put it equals to 10 cos 20. So I can take it to the other side. So it will give me P sine theta equals to 10 cos 20 minus 10 sine 20. Now pick up your calculator. I am doing calculation now. P sine theta. Give me a second. Okay. So it is 5.97672. So this is my equation number. Because question says obtain an equation, so you can leave it here and call it 2. And this is my simplified form of the equation. Now the target is here in part C, use your equations in A and B to find out the unknown forces. So I can divide equation 4 by 3. Why? Divide equation 4 by equation 3. What comes in your mind? Why I'm doing so? Absolutely right. You can substitute also, your choice, but I am seeing here that sine theta over cos theta will become tan theta and life will be easy for me. So I am dividing it by P cos theta. Right. So it will become 7.817127. So this cancels out and you get tan theta. Divided tan theta equals to 0.764567. So you get the value of theta. Give me a second. Okay. So it is 37.4. So your angle is 37.4, always circle or highlight the answer finally so that examiner can see the answers quickly at a glance. So now you can use equation 3 or 4, whatever you like, to get the value of P. So suppose I am using equation 3, which is here. I will use P cos theta will be 37.4 is equals to 7.817127, and then divided by cos 37.5, your P will come 9.84 Newton. So this is how you will resolve the forces, and because it is an equilibrium, you will balance them and then form an equation to get the answer. So now it is the test of your understanding. Achha, by the way, if examiner is not asking right into the exact form, you can use calculator. And of course, sine 20, except sine 30, 60 and 45, we don't get exact answer. So mostly when exact answer is asked, the question or the angle must be given in 30 and 60, like in this question. So you can put the video on pause and try it. I am solving it here. And I have tried to solve here by showing the exact form, because there are exact surds for 30, 60 and 45 degrees. Okay. So I'm showing you the answer now. Now I'm not explaining, I'm just showing it so that you can check your answer with this. If you have any query, you can write it into the comment and I'll explain it. But I'm showing it slowly, not showing the whole page in one go, then it becomes difficult to match with the answer. So this is along the OX or along the X direction, the forces which are acting. You can see I have used different color, green, blue and red. This is along Y axis. After that, definitely we are trying to solve them simultaneously to get unknown values, which are P and Q. Since green is the simplified form of along x-axis, and this is a simplified form of along y-axis, either upside or down, and then solving them simultaneously. So I have used different color to show very clearly that this value of P I am substituting here, and that's why I put it in the bracket here. So I'm repeating, this value of P is being substituted here. After that, you have to be careful if it is exact form. Otherwise, so in calculator, you can substitute answers, all the answers, and get the Q value immediately. But I have shown all the steps to show if it is exact form question, then how will you carry it. And then substitute this value of Q here to get the value of P. So you can say I have substituted the value here in equation 3. I have mentioned here which equation I am using to get the answer. So I hope this is clear. Now you can take your assessment. Here is a little simple question, because we always ask a student to assess themselves. During you test your understanding, you can discuss questions fine. But now you assess yourself. I'm just completing the diagram in front of you, and then I will show you the solution. You can put the video on pause if you want. This angle will be 45. So this will be 5 root 2 cos 45. This will be 5 root 2 sine 45. And this P and this is angle theta. So this is P sine theta. This is P cos theta. Right? And now you can see how I've solved. So along OX, I have resolved the forces. This is your assessment. You can mark yourself for every step 1 mark. And then we will do what? Division or substitution also you can do. And then you will get P. So I hope you understood, and you can write your query in the comments. In the next video, I will explain next topic, which is when objects are in motion. Particle is in motion. Thank you very much for watching the video. Please press like and subscribe button and share it with your friends.